Schrödinger's cat, the paradox that questions reality. Imagine walking into a room where a single black box sits quietly on a table. It is completely sealed. No windows, no sound, no way to know what is happening inside. At first glance, it looks ordinary, almost boring, yet hidden within that simple box is an idea so strange that it has challenged scientists and philosophers for nearly a century. Now imagine someone tells you that inside the box there is a cat. They also tell you that until the box is opened, the cat is both alive and dead at exactly the same time. It sounds like nonsense. It sounds like a magic trick or a science fiction story. Yet this impossible idea became one of the most famous thought experiments in the history of physics. The strange part is that the paradox is not really about a cat. It is about reality itself. Every day we experience a universe that appears solid and predictable. A cup falls and breaks. The sun rises every morning. We believe objects possess definite properties whether we look at them or not. A tree remains a tree even when no one is watching. But what if the universe behaves differently on its smallest scales? What if certainty is nothing more than an illusion created by observation? To understand this mystery, we must travel back to the early 20th century when physicists began exploring a world smaller than atoms. They expected to discover tiny versions of everyday objects. Instead, they found something that seemed to ignore common sense completely. Electrons refused to behave like tiny balls. Light acted as both a wave and a particle. Matter seemed to exist as probabilities rather than definite objects. Instead of describing what something was, the mathematics described every possible thing it could become. This idea became known as superposition. Imagine flipping a coin. Before it lands, you know it will become either heads or tails. Quantum mechanics suggests something much stranger. Until the coin is observed, it behaves as if every possible outcome exists together in a cloud of probabilities. For microscopic particles, experiment after experiment has confirmed predictions that seem impossible from the perspective of everyday life. Many scientists accepted these strange equations because they worked perfectly, even if nobody truly understood what they meant. One of those scientists was Erwin Schrödinger. In 1935, he proposed a thought experiment that would expose the bizarre consequences of quantum theory. He did not intend to prove that reality was strange. In fact, he hoped to show that applying quantum rules to everyday objects produced absurd conclusions. His imaginary experiment begins with a cat placed inside a perfectly sealed box. Alongside the cat is a tiny radioactive atom. Radioactive decay is completely random. During the next hour, the atom has a 50% chance of decaying and a 50% chance of remaining unchanged. Connected to the atom is a detector. If the detector senses decay, it activates a hammer. The hammer breaks a glass vial. The vial releases poison. The poison kills the cat. If the atom does not decay, nothing happens, and the cat survives. Simple enough. But quantum mechanics introduces a shocking twist. Before anyone opens the box, the atom exists in a mathematical superposition of both decayed and not decayed states. If the atom is simultaneously both possibilities, then the detector is simultaneously triggered and not triggered. The hammer both falls and does not fall. The poison is both released and contained. And the cat becomes both alive and dead until an observation is made. Take a moment to think about how strange this really is. Not uncertain, not hidden, not simply unknown. According to the mathematics, both realities exist together. Our intuition immediately rebels against this idea because nothing in our daily lives behaves this way. Yet every successful prediction of quantum mechanics seems to point toward a universe far stranger than human imagination ever expected. Some physicists accepted this interpretation and argued that observation causes the wave of possibilities to collapse into a single reality. Before observation, there are many possibilities. After observation, there is only one. This became known as the Copenhagen interpretation and remains one of the most influential ways of understanding quantum mechanics. But it creates an uncomfortable question. What exactly counts as an observation? Does a human need to look? Does a camera count? Does a molecule count? Where is the boundary between possibility and reality? No one knows. Other scientists found this explanation deeply unsatisfying. One alternative became even stranger. Instead of collapsing possibilities into one outcome, every possible outcome actually happens. The universe simply splits. In one universe, the cat survives. In another universe, the cat dies. Neither possibility disappears. Instead, reality branches endlessly into countless parallel worlds. Every decision, every quantum event, every possibility creates another universe. Somewhere there could be another version of you who chose a different career, another version who never watched this video, and another version living a completely different life. The many worlds interpretation sounds like science fiction, yet it follows naturally from the mathematics without requiring wave function collapse. Then there are hidden variable theories. These propose that reality is always definite. Particles always possess exact properties. We simply lack enough information to know them. The uncertainty exists only in our knowledge, not in the universe itself. For decades, physicists debated these possibilities. Then experiments became increasingly sophisticated. Scientists tested quantum behavior with larger and larger objects. Individual atoms displayed superposition. Molecules displayed superposition. Tiny mechanical devices displayed superposition. Every successful experiment reinforced the strange predictions of quantum theory. The universe continued refusing to behave according to common sense. Today, these bizarre principles are no longer just philosophical puzzles. Quantum computers exploit superposition to perform calculations in entirely new ways. Quantum cryptography promises communication protected by the laws of physics themselves. Quantum teleportation transfers information across astonishing distances. Ideas that once seemed ridiculous are becoming technologies that may transform civilization. Yet the deepest mystery remains untouched. What is reality? When you look at the night sky, are you seeing a universe that exists independently of you? Or is observation somehow woven into the fabric of existence? Philosophers have debated similar questions for thousands of years. If a tree falls in an empty forest and nobody hears it, does it make a sound? Quantum mechanics transforms that old question into something even stranger. If no conscious observer ever existed anywhere in the universe, would reality still possess definite properties? Or would existence itself remain suspended in endless possibilities? No experiment has provided a final answer. Perhaps reality is fundamentally probabilistic. Perhaps infinite universes exist beyond imagination. Perhaps a deeper theory waits to be discovered, one that will make today's mysteries seem simple. Schrödinger's cat has never existed outside imagination, yet it continues to challenge every assumption we hold about certainty, observation, and existence. The greatest scientific discoveries often begin with impossible questions. This paradox reminds us that the universe is under no obligation to make sense to human intuition. The box still sits before us, silent, closed. Inside, a simple cat waits in the strange mathematics of possibility. And as long as the lid remains unopened, one final question continues to echo through physics and philosophy alike. Are we discovering reality or creating it every time we choose to look?